seen a scenario in your circuit, like for example, you have a microcontroller 1, you have a microcontroller 2. Let us assume this is powered by voltage V1, okay, and then this is powered by voltage V2, okay, and let us assume they are connected by watt, okay. So now this is a microcontroller 1 and this is microcontroller 2, okay. So now let us assume a scenario where V2 is turned off. That means V2 is equal to 0 volts and V1 is still powered up. So in that cases, sometimes what happens is you might see this microcontroller still turned on, even though you have given a 0 volts here, and in an appropriate condition where it is not even properly reset. So this kind of scenario can happen, and this generally happens because of something called injection current. What do you mean by injection current? Injection current is something is nothing but the current that flows into the pins of a microcontroller when the voltage that is applied on the pin is either greater than VCC of that particular microcontroller, VCC value of that microcontroller, are less than the ground potential. So in such case, what happens is these pins, whatever are there on the microcontroller, might have protection diodes, right? So these protection diodes might turn on, and this induces leakage in this particular IC, leading to injection current. A very very important phenomena to understand in microcontrollers. So if you are experiencing this kind of scenario which we talked, it might be due to the injection current, sorry. So now if we actually see the STM32 datasheet, we actually can see the injection current, IO injection current specifications, and sometimes this injection current might damage the IC. Sometimes it also can cause minor leakages where the product will not get affected. So if you see here, this is the data sheet of STM32F 103C66, where have the injection current specified for each and every pin. So you can see the maximum injection current that is accepted by this is 5 milliamps, or the negative 5 milliamps, where it is flowing in the opposite direction. So while designing your circuit, it is very very important that we don't exceed this current, otherwise the IC gets damaged. So injection current is harmful, but unless you don't have current exceeding the maximum value, it might not damage, but still it might function inappropriately. And in a worst case, in the case of a microcontroller, it could lead to improper reset condition occurring. And unless you power up both the devices that are connected on these specific circuits, the circuit might not function properly. A very important phenomenon. So one important aspect that we can see from the design side is when we are connecting two devices, as we have shown, it is better we have a series resistor, especially on the TX side and towards the RX side, so that we limit the amount of current that goes in. So this resistor should be calculated appropriately in your design. So hope you got a view of injection current. Please let us know if you have any questions. Thank you.